Connolly. I started making videos for my students, but then I decided that I wanted everybody to learn during this crazy time. So if you have any topics you want me to cover, please reach out, connollymathathome@gmail.com. I'll be happy to answer any of your questions, and if you need a video made, I'll make it and send it right back to you. So let's get started. So for math time today, we're going to be talking about adding fractions that have the same denominator using the number line representation and using an area model representation. Okay, so let's get started. Let's think about if we're talking about eighths and we have 1/8 plus 4/8. Okay, so what we need to recognize right now is that we're working with the same size pieces. So eighths are the same size pieces, which means we can combine them. In 5th grade, we learn about when we're working with different size pieces and we have to take some additional steps to make sure we can combine the fractions. So just want to point that out, that the reason that we can just combine them is because the denominator is the same. So let's think about representing 1/8 and representing 4/8. And we can even do that on the same area model if we want to. So let's just think about this real quick. So if this was halfway, and remember when we are representing fractions, those are not equal pieces. So sometimes you need your eraser and you have to rework the pieces a little bit. So, and that's okay. So we're not all going to be perfect the first time or the second time. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 equal pieces here. And what I'm going to do is I'm going to represent my first addend here with the green marker. So I have 1/8 shaded in. And I'm going to add 4 more eighths with my red marker. So I'm going to represent the 4/8 in red. And I want you predicting how many eighths are represented total after I've represented both. So we're going to combine the two amounts. So what is 1/8 plus 4/8? I see 1, 2, 3, 4, 5 eighths. Okay, so I wonder what's happening here. Something we should be thinking about. What's happening when we add fractions, what happens with the denominator, and what happens with the numerator just when we're adding fractions. Okay, so that's what we could do to show this on this same area model. Okay, and some of you might be tempted to also draw 1/8 here. Did I do that right? No, I did not. I was trying to make 16ths, my bad. Okay, so let's start over again. So 1/8 here, and some people might want to do 4/8 here to represent. So I represented 1/8 on this area model, 4/8 on this one. Also taking note that my holes are the same exact size. I drew my rectangles as close to the same size as possible. And you can still see 1/8 plus 4/8 would give us 5/8. What's really important that I need for you to understand is that I am dealing with eighths only, okay? Do not get tempted to draw a different number of parts in each hole. We're dealing with eighths, so that's what we're representing, okay? If you're working towards efficiency, let's work on the same area model. But I want to give you all the options. And the last way that we can think about adding these fractions is by using our number lines. So if you were adding whole numbers, which I'm going to do here real quick. So if you were doing 16 plus 42, for example, you would take the larger addend, most likely, so you do less work, and you could add in parts. We could add 10 first, and then we could add 6 and get 58. Or if you were working with smaller numbers like 1 plus 4, and you wanted to show 1 plus 4 on the number line, you would start with 1, or 4 actually, and add 1, 2, 3, 4 jumps. And that's what we would do with whole numbers. So what we're going to do, and we labeled it plus 1, plus 1, plus 1, plus 1. What we're going to do with fractions is the same thing. We're going to use the number line the same exact way. So let's think about our number line. And you could start with 4/8 because that fraction is larger and adding 1/8 would be less work. So if I was starting with 4/8 on my number line, and I would label my jumps all the time on the number line, plus 1/8 and end at 5/8. So 4/8 plus 1/8 is 5/8. Or you could start at 1/8 and add the 4/8. So plus 1/8 plus 1/8. Sorry, I should be labeling this. So 1/8 plus 1/8 is 2/8. 2/8 plus 1/8 is 3/8 plus another 8. So I've added 1, 2, 3 is 4/8. And I know I need to add 1/8, 2/8, 3/8, 4/8 to get to my final answer. Okay, so those are two different ways that we can show our addition on the number line. I'm going to get into some situations where it gets a little more complicated too. So stick with me, we're going to keep working. So what we've done is we've shown combining the two amounts on an area model, and if we're working towards efficiency, we might want to use the same area model, but not required. And we're also showing adding on the number line, so combining the two amounts there. All right, so let's do one more where our answer is less than a whole. You'll see what I mean in just a second. So let's say we're doing 3/6 plus 2/6, and we're trying to figure out what that equals there. So area model, I'm going to make 6. I'm going to shade in 3/6 in green. And since I'm working with the same size pieces, I can shade in 2/6 here in red. So when we think about the total, when we combine the two amounts, we see that 3/6 plus 2/6 is clearly 1, 2, 3, 4, 5. 5, 6. Okay, so something is still happening that I want you to notice about the denominator and the numerators each time. This is a noticing that you should be thinking about. And then we can also represent our addition on the number line. So I'm going to take my add-in 3/6. Add-ins are the numbers that we're adding together, the numbers we're combining. I'm going to start with my add-in 3/6, and I'm going to show that I've added 2/6. So plus 1/6 is 4/6. Plus 1 more 6 is 5/6. So after I started with 3/6 and I added 1/6, 2/6, I land on 5/6. So where is my answer in the number line representation? 3/6 plus 2/6 is 5/6. So that answer in this representation is down here. Okay? So that is one way that we can think about combining fractions. There's other ways too, so let's get to it. Sometimes you're going to add two fractions together that might get you greater than a whole. So let me explain what I'm talking about. Let's say that I ask you to add together 3/4 plus 3/4. Okay, so let's get down to the area model representation first. So 3/4. I'm going to shade it in red here. 3/4 is represented. As you can see, in this whole, there's 1/4 left. But I need to add 3/4. So what do? Well, some people are going to be tempted to draw one area model and represent 6 altogether on the area model. And sometimes when we end up doing that, we end up with 8ths, and I don't want that to happen. You need to keep track of what's happening. You're adding 3/4. So I still need to add 3 of these same size pieces. So I'm going to draw another area model. Okay, I'm going to keep it the same size because when we're talking about equal size parts, they should be equal size parts, and that means equal size parts of the same whole. Now I'm going to add my 3/4 in green. Okay, so I'm going to add a 1/4 there, 1/4, 2/4, 3/4. So what happened? Let's count the total number of 4ths that we're working with. 1/4, 2/4, 3/4, 4/4. We're still adding 4ths. 5/4, 6/4. So we have 6/4. What do you notice about 6/4? I think that you're noticing from the representation and conjectures if you watched the comparing fractions videos that 6/4 is greater than 1/2. We know that because the numerator is greater than the denominator. So let's think about this whole. We have one whole shaded in here. Do you notice the whole entire thing is shaded? How many 4ths is that? 1/4, 2/4, 3/4, 4/4. So when I'm decomposing 6/4, I can break that into 4/4 plus, how many more 4ths would you need to make 6/4? Do you see the 2/4 down here? So if you were doing this without a representation, even though you should rely on your representations, you might notice that 6/4 is the same as 4/4 plus 2/4. So you might have noticed that it's the same as 1/2 and 2/4. And we write it like this, 1/2 and 2/4. So when you have a fraction that's greater than a whole, you have reached the correct answer. But I also want you thinking about how to write it as a mixed number. These two here are equivalent. So just be thinking about that. All right? So what does this look like on the number line? So we just covered the area model, and I'm going to cover the number line next. And I'm going to show you a couple different ways we can think about this. Okay? So we have our first number line here. And I'm going to start with 3/4. And I know that I have to add 3/4. So I'm going to do the same thing that I did last time where I add 1/4 at a time. So I label plus 1/4, 4/4, plus 1/4, 5/4, plus 1/4, 6/4. So I have added, I started at 3/4, I added 3/4, and we know that our answer is there. Okay? Another thing that might be helpful to do, and we'll do one more example of this after, is if you know that 3/4 plus 1/4 makes 4/4, you can also label that 1/2 because you know 4/4 is a whole. Then from there you can do a jump of 1/4 and a jump of 1/4, or if you want, you can add the other 2/4 all at once and end up with 1 2/4. So I still see that I started with 3/4. I still see the 3/4 that I added, and I still see my answer here, 1 2/4. Okay? Math is so much fun because there's so many different ways to solve and think about things. So just wanted to put that on your radar. Okay? So I'm going to do one more example, then I'm going to give you some examples to try in your own. Alright, so this time, let me just readjust here. This time, let's say that we're starting with 3/8. And I want to add 7/8. Okay? So we're going to start with 3/8 and add 7/8. So let's get I'm going to do eighths this way just because they got so skinny last time. I'm going to represent my 3/8 with my red marker here. 1, 2, 3. And then I have to add 7/8 from there. So let's see what happens. 1, 2, 3, 4, 5. I've only added 5/8 so far. So what do we do? If we've shaded in an entire hole, we have to draw another. We split it into the same size pieces again, and we continue. So I've done 1, 2, 3, 4, 5 out of 7/8. So I know I need to do 6/8, 7/8, 2 more. Okay, so let's count the number of eighths that we're at. 1, 2, 3, 4, 5, 6, 7, 8. Or you might have already seen that that's 8/8. And then down here, 9, 10. We have 2 more eighths. So total, we have 10/8, which is a correct answer. It's also written as a fraction that's greater than a whole, because the numerator is greater than the denominator. So one thing that we think about doing is making an equivalent mixed number. So when we think about how many holes are shaded in, we know 8/8 is 1 hole, and there's 2 more 8s left over. Now, making these whole numbers is another important thing to think about when we're adding with what I'm going to show you next. Okay, so whole numbers are friendly. We love whole numbers. When we're working with fractions, we want to use them to our advantage. They're going to help us, especially when we get to 5th grade, and especially when we're working with mixed numbers too. So let's think about 3/8 plus 7/8. Okay? As you know, order does not matter when we're adding. Okay? So you could start with 7/8 and add 3/8, which might result in less work because you only have to add 3/8. So that's what I'm going to do here. Okay? Then I'm going to start with 3/8 and show you another way to think about it too. So if I have 7/8, I could add 3/8, labeling my jumps each time. 7/8 plus 1/8 is 8/8. Plus 1 more 8 is 9/8. Plus 1 more 8 is 10/8. Again, there's more than just these 2 ways to think about it. Then I also want to show you another number line situation. Let's say we decide to start at 3/8. Okay? How many 8ths does it take to make a hole? 1 hole. The whole thing shaded in. What did we just see? Well, I know when the numerator and denominator are the same, that I have 1 hole. So what I'm going to do, instead of adding 1/8 at a time, I am going to add 5/8. Why? Because I know that 3/8 plus 5/8 is 8/8, and I know 8/8 is 1 whole. So let me just do that real quick. Plus 5/8. I'm at 8/8, which is the same as a whole. You can label it either way. So I started at 3/8. Let's make that look more like a 5. I added 5/8, and I'm at 1 whole, which is the same as 8/8. So then I'm going to say to myself, I've added 5/8 so far. I need to add 2 more 8s. So you could go like this. Plus 1/8 is 1 and 1/8. Plus 1/8 is 1 and 2/8. That's one option. Or if you wanted to do 1 jump, you could have labeled it plus 2/8. Do you see that I've added the 7/8? I added all 7 eighths. I started at 3 eighths. I added 5 eighths and then 2 more eighths, which is 7 eighths, and I landed down here at 1 2 eighths. So, why did I do it that way? I know how to get to one hole. I know what I need to add to 3 eighths to make a hole. This is a friendly number. It makes me smile because then I'm like, well, I know what 1 + 2 eighths is. It's 1 2 eighths. So that's why I chose to do that strategy. Could we have done that up here? Yeah, we totally could have. Okay, you can do, if your sum is going to be over one whole, I want you thinking about getting to that friendly number, which in this case would be a whole number. They're easier to work with, so we like to use them. So be thinking about that. Okay, so let's go over what you learned. We learned that we can combine these fractions because they have the same denominator. So we're dealing with the same size pieces. Once you were given an expression, we represented one of the fractions on the area model, and then we represented the other one. If we ran out of space on one area model because we got to one whole, we created another one of the same exact size and continued adding the number of eighths that we needed to add. Then we thought about it on the number line, and we thought about adding one at a time, or we thought about adding up in chunks, which you can do just like with whole numbers, which makes it exciting. Okay, so here's some that I want you to try at home by yourself. All right, so I would like for you to work on, with a representation, 1 8 plus 5 eighths. Then I want you to do 3 fifths plus 2 fifths. I wonder what's going to happen there. Then I want you to do, let's see, 3 fourths plus 2 fourths. And I want you to see what happens there. I'm going to give you a fourth one because there's another situation that I want you to tackle. So 1 8 plus 5 eighths, 3 fifths plus 2 fifths, 3 fourths plus 2 fourths. Then I want you to think about 4 6 plus 4 6. I just like math so much, I'm giving you an extra one today. Okay? So reach out if you have any questions, and subtracting fractions with the same denominator is next. Bye.